Okay, so to find the critical points, first we need f prime of x. We're going to use the power rule. So the exponent comes down and reduces by 1. 72 times 2 is 144. To find this first group, we need to set our derivative equal to 0 and solve. So we can factor out the greatest common factor of 4x. Set each factor equal to 0. So here x equals 0. And when you square root both sides, you get x is plus or minus 6. You can't forget that plus or minus. So now the critical values are negative 6, 0, and positive 6. We have to do the first derivative test to find where we have a max or a min. So I'm going to make a little chart here and put my values in order. We're going to pick any value less than negative 6, so let's choose negative 8. Any value in between, negative 1. Any value in between here, and a value out here. And we have to plug those into f prime to find out if it's positive or negative. So f prime of negative 8 will give us a negative answer. This will give us positive, negative, and positive. So that means our actual original function is decreasing, increasing, decreasing, and then increasing. So when we go from decreasing to increasing, so it makes these patterns, so I know at negative 6 is a minimum. So there's some y value minimum at x equals negative 6 and positive 6. And there's a maximum value at x equals 0. So to actually find the y value, that is the max or min, we're going to plug those numbers back into the original f of x. So back into this original function. So we get f of negative 6 is negative 1,313. F of 0 is negative 17. And f of 6 is negative 1313. So our max is a value of negative 17 at x equals 0, and our minimum is negative 1,313 at negative 6 and 6. So now for our increasing and decreasing intervals, we have our answers right here in the chart. So we are increasing between negative 6 and 0, and again from 6 to infinity. And we're decreasing from negative infinity to negative 6, and again from 0 to 6. We're going to repeat a similar process to find the inflection points in concavity, but we need the second derivative for that. So I'm going to take the derivative of my first derivative. I get 12x squared minus 144. So now to find these key values, I have to set my second derivative equal to 0 and solve. So I can factor out a 12. Set my factor equal to 0. And when I square root, I get plus or minus root 12, which 12 is 4 times 3, so that is plus or minus 2 root 3. So now I'm going to make a chart just like we did for the first derivative, but with the second derivative. I'll get negative 2 root 3 to test, and positive 2 root 3. So when I plug a value that is less than negative 2 root 3, Let's choose negative 20. When I plug that into the second derivative, I get a positive value. When I plug in 0, I get a negative value. When I plug in positive 20, I'm going to get a positive value. So that means our graph is concave up when the second derivative is positive, concave down when it's negative, and up again. So because we change concavity at negative 2 root 3 and positive 2 root 3, those are the two x values of the inflection points. Now an inflection point is a coordinate, so I'd have to find the y value. So using my original graph, I'm going to plug in negative 2 root 3. So that's the original function we started with up here at the top. The 4x to the 4th minus 72x squared minus 17. And when I plug in negative 2 root 3, I get negative 737 as a y value. So this is the coordinate of the first inflection point. Now when I plug in 2 root 3, I'm also going to get negative 737. So let's make this plus or minus 2 root 3 and the y coordinate. Now we're concave up from negative infinity to negative 2 root 3. And again from 2 root 3 to infinity. And then we're concave down in between negative 2 root 3 to positive 2 root 3. Okay, so we're going to repeat that whole process for the next problem. So let's find the first derivative. We have to set it equal to 0. And I notice all of these terms can be divided by 3. So I'm going to divide everything by 3 to make my factoring easier. So what multiplies to negative 5 that adds to negative 4? We're going to choose negative 5 and positive 1. Set each factor equal to 0. So x is 5 or negative 1. So those are my two critical values. So I'm going to make my chart. Plug the values into f prime. See if I get a positive or negative. So let's choose negative 4, 0, and 10. When I plug in negative 4, I got a positive value. When I plugged in 0, I get a negative. And 10, we get a positive. So increasing to decreasing, decreasing to increasing. So we have a max at negative 1. And we have a min at x equals 5. But we have to find that actual y value. So using my original function, f of x, when I plug in negative 1, I get 13. And when I plug in 5, I get negative 95. We're increasing from negative infinity to negative 1 here. And again from 5 to infinity. We're decreasing between negative 1 and 5. Now we need our second derivative. So I'm going to take the derivative of f prime. 6x minus 12. So let's set that equal to 0. And solve, we get x is 2. So I'm going to choose a value that's less than 2 and more than 2 to test into my second derivative. When I plug in 0 here, I get a negative. When I plug in 4, I get a positive. So that means this interval is concave down because the second derivative was negative, and this interval is concave up. Because our concavity changes, we do have an inflection point at 2, but I have to find this y value. So using the original function again, because I need the y value on the original, when I plug in 2 to f of x, I get negative 41. And then using my chart for my intervals of concavity, we're up from 2 to infinity and down from negative infinity to 2.